Hello friends, welcome to Career Cluster. This is part 3 of our detailed learning of artificial intelligence and its topics. Today we are going to discuss about deep learning, its uses, advantages, disadvantages and how it is different from ML, that is machine learning. This concept is very helpful for your understanding and interview preparation. Refer our shorts for quick revision. If you are new to this channel, please don't forget to subscribe. Please share your thoughts by commenting. Let's get started. What is deep learning? Deep learning is a branch of machine learning using multi-layer neural networks to learn from large data automatically. Deep learning is a subset of machine learning that uses artificial neural networks with many layers. It automatically discovers patterns in data without human intervention, making it ideal for complex tasks like understanding images, speech, and natural language. If you are not understanding machine learning, please refer our second video. You can understand. The deep learning is a subset of machine learning. How it works? Deep learning is being used in face recognition, speech recognition, and image classification, ChatGPT, and self-driving cars. Deep learning lets machines see, hear, and understand like humans. Why deep learning? Traditional machine learning requires manual feature engineering. Humans must tell the system what to look for. Deep learning eliminates this step by automatically learning relevant features from raw data, making it far more powerful for unstructured data like images, audio, and text. There are some limitations in the ML, traditional ML limitations. Manual feature extraction, limited with unstructured data, and struggles with complex patterns. These are few limitations with ML. And with deep learning, higher accuracy outperforms traditional ML on complex tasks, handles large data, performance improves with more data, learns complex patterns, automatic feature extraction from raw data, supports generative AI, powers ChatGPT, DALL-E, and Midjourney. How deep learning works? The learning process, an iterative cycle of predictions and corrections. So it is an iterative process. It predicts, and if it is doing good, then it improve on that same prediction. And if it requires any improvements, then it correct its results and it will improve itself. The learning process is iterative. The model makes predictions, measures how wrong they are using loss functions, then adjusted internal parameters, that means weights, to reduce errors. After thousands of iterations, the model becomes highly accurate at its task. The steps involved in the working process. First one is input data. In this process or in this section, feed raw data like images, text, and audio. Next step is prediction. In the prediction stage, network makes initial guess. And next stage is calculate error. In this stage, compare predictions with actual results. And next stage is adjust weights. Back propagation updates parameters. And finally, improves predictions. repeat until accurate. So it is an iterative process. So all these predictions and calculate error, adjust weights and improve predictions, all these stages works in the iterative model. This cycle repeats thousands of times until the model achieves high accuracy. Neural network architecture. A deep neural network has multiple layers stacked together. Each layer in a neural network transforms data into increasingly abstract representation. Early layers detect simple patterns like edges and colors. Middle layers combines them into features, shapes, textures, and final layers makes high level decisions. This is a cat, this is a dog kind of decisions. So these are final decisions. So it has three different layer kind of architecture. So early layers, middle layers, and the final layers. So in early layer, it identifies very simple patterns. And in the middle layers, it identifies features. And in the final layers, that generates an ultimate decisions. And this involves input layer receives raw data like pixels, words, or numbers. Next, hidden layers. In hidden layers, extract features, learn patterns, that is deep part. And output layer produces final predictions or classifications. Here, deep means many hidden layers. More layers equal to more complex patterns learned. So if it is a single task, it will contain very less number of layers. Input layer, output layer, and in the middle there will be hidden layers. So if it is a complex task, it will achieve it with multiple layers. Yep. Forward and back propagation. Forward propagation passes data through the network to generate a prediction. This is forward propagation, and the result of forward propagation is it generates a prediction. And back propagation then calculates how much each weight contributes to the error and adjust them accordingly. So if there is any correction is required, then it will follow back propagation, then it corrects its weights. This two-step process is repeatedly repeated millions of times during the training. Okay, what is forward propagation and how it works? Data flows from input to output. So this is a one directional one. Data enters input layer, passes through hidden layers. Each neuron applies weights plus bias. Output layer gives prediction. So this is a forward propagation. And back propagation. In back propagation, it applies when there is any correction or error occur. So it means error flow from output to input. So it is in the reverse order. In this process, it calculates loss, that is error. It computes gradients, propagate error backward, update weights to reduce error. Key insights here is forward pass makes predictions and back propagation learns from the mistakes. Popular deep learning models. Different architecture of different types of data. Different architecture excels at different tasks. CNNs use spatial filters perfect for images. RNNs or LSTMs process sequences one step at a time. ideal for time series data. Transformers uses attention mechanism to process all data simultaneously, making them the most powerful and versatile architectures today. Okay, what is CNN and what is RNN? CNN. So we can discuss about the CNN and RNN in the upcoming videos in detail. What is CNN? It is convolutional neural network. It is best for images, image recognition, object detection, and medical imaging. RNN or LSTM, recurrent neural networks. It is best for sequential. It is being used in time series, speech, and music generations. And what are transformers? So we can discuss in detail in the further videos. The transformers are attention based models. This is best for GPT, Claude, and Gemini. These are used in text generation, translations, and reasoning. Transformers dominate modern AI, powering all major LLMs today. Training concepts in the deep learning. Key terms you need to know for training deep learning models. They are: training a deep learning model requires careful tuning of hyperparameters. The learning rate controls how big each weight adjustment is. Too large and the model overshoots. Too small and it learns too slowly. Batch size effect, memory usage, and training stability. These concepts are epoch. What is epoch means? One complete pass through the entire data set. Example, 50 epochs or 50 epochs equal to data seen 50 times. We can discuss this further in upcoming videos. And the second concept is batches. Batches is a subset of data processed at once. Example, batch size of 32 equal to 32 sample per step. And loss function. So whenever there is a back propagation, this comes into picture. It measures how wrong the prediction is. For example, your expected value is 5, but it is predicted the value as 2. So it will predict the distance between the expected value and actual value. It measures how wrong the prediction is. MAC, cross entropy, and binary cross entropy. These are few concepts in the loss functions. We can discuss them. Optimizers. Optimizers is algorithms that adjust weights efficiently. So few algorithms are ADAM, SGD, RMS probe, AdaGrad. ADAM is the most popular optimizer, combines momentum plus adaptive learning rates. We can discuss this in upcoming videos. Some challenges of machine deep learning. Deep learning models are often called black boxes. So what is black box? You primarily listen this word in black box testing and white box testing. So you cannot understand what is happening inside that particular module, but it generates output. So this is the same with these hidden layers. That is, deep learning models are often called as black boxes because it's difficult to understand exactly why they make specific decisions. This lack of interpretability is a major concern in critical applications like healthcare and autonomous driving when explanations are required. It means it generates some output, but it is very difficult to understand. So these challenges are overfitting. Model memorizes training data, fails on a new data. Dropouts, regularization, more data. That is one challenge. And underfitting. Model too simple to capture patterns. More layers, more training, better features. Large data required. To generate a accurate data, it requires very large data. It needs massive data sets to perform well. So transform learning and data augmentations required. Expensive hardware requires GPUs or TPUs for training. It requires cloud computing and model optimization. The main disadvantages, main challenge is black box nature. It means very hard to explain why model made a decision. It requires XAI techniques, attention visualization. Understanding these challenges helps you build better models. So we can discuss these in detail in upcoming videos. Some real world applications. Deep learning is transforming every industry. Deep learning has moved from research labs to everyday products. Every time you use face unlock, talk to a voice assistant, get a content recommendation, or use an AI chatbot, deep learning is working behind the scenes to make it possible. Some applications are healthcare. In healthcare, it is being used like disease detection, drug discovery, and medical imaging. And it's being used in finance. In finance, fraud detections, algorithmic trading, and risk assessment. It is being used in retail. In retail, how it used? Recommendation engines, demand forecasting, visual search, and transportation. In transportation, self-driving cars, route optimization, and traffic predictions. And it is also being used in generative AI. The examples are ChatGPT, DALL-E, Midjourney, and Stable Diffusion. Deep learning powers billions of daily interactions from search results to voice assistants. Quick revision. Understanding these core concepts give you the foundation to explore any deep learning topic further. The field is evolving rapidly. New architecture and techniques emerge regularly, but these fundamentals remains constant. Core concepts are neural networks, layers, neurons, weights, bias, and activation function. Some learning concepts are forward propagation, backward propagation, gradient descent, and loss function. Some training concepts epoch, batch size, learning rate, and optimizer. Important models discussed here CNN, RNN or LSTM, transformers, GAN or autoencoder. Some common problems we discussed: overfitting, underfitting, vanishing gradient, and data hungry. Master these concepts and you have a solid foundation in deep learning. So we will discuss all these topics in future. Thank you for watching. If you have any doubts, please comment. Please like, share, and subscribe. Thank you again.